Hi guys, so here's an example problem where we've got multiple resistors in a circuit and we are trying to just figure out the equivalent resistance of this. So we're not concerned about the voltage or current. As a matter of fact, we're not given any information that would allow us to calculate those things. But we do have the resistances of the individual resistors, and we want to figure out the equivalent resistance of the circuit. So if I could just take all of these resistors and combine them into one resistor and replace all these with just one resistor, what would the value of that resistor be? So that's our goal. I've given myself a little room to write here, and we'll talk about the process. Let's see. So the first thing that I have to do is I have to kind of look at this circuit and figure out, well, what's my first step? What should I do? And so what we should look for is combinations of resistors that are very clearly either straightforward series or straightforward parallel combinations. So one thing that jumps out to me really quickly is that if I look at this, I can see that, well, R3 and R4 are in series with each other. So what I can do is I can figure out what their equivalent resistance is if I combine those two together. I'm going to call that equivalent resistance R sub A for lack of anything better. I'm just making up a subscript. And I'm going to add those two resistors up in the way that I should because of the fact that they're in series. And this is our formula for adding series resistors. Each one of these is 10 ohms. So the equivalent resistance there is 20 ohms. Okay. So at this stage, what I should do is kind of redraw this circuit and replace those two resistors with just the single resistance that I figured out. That's at R sub A. All right, so I'm going to move forward onto the next slide because I actually have that circuit written out. All right, so I know that R sub A is 20 ohms, and here's my new circuit that I'm working with. And again, what I'm looking for is combinations of resistors that are either very clearly series or very clearly parallel. So one thing that jumps out now is this combination of R2 and RA. They're in parallel lines, and I can add them together. Of course, when I do that, I've got to use the formula for adding parallel resistors. Now, some of us might be wondering, well, why can't I just go ahead and look at R1 and R2 and say that R1 and R2 are in series with one another and add those together? Well, the issue with that is that R1 and R2 are not in a simple series with each other. Why? It's because of the fact that, look, this split right there, that split gets in the way of this being a simple series combination. So trying to add R1 and R2 together as if they're in series just isn't going to work. Oops. All right, so what I really need to do is I really need to add R2 and RA together using my rule for adding up parallel resistors. So this says that 1 over my equivalent resistance is 1 over R2 plus 1 over RA. So 1 over RB is, let's see, R2 is 40 ohms. RA is 20 ohms. 20, there we go. And now if I add these guys together and do the math and plug this into my calculator, what I get out is that the equivalent resistance is 13.3 ohms. All right, and would very much encourage you to work that out yourself on your calculator, because you can do this and now have a check to make sure that you're doing this calculation correctly. I know that people can get tripped up using the formula for adding parallel resistors together. So that's our equivalent resistance of R2 and RA added together. And what we're going to do now is we're once again going to redraw the circuit. So I'm going to hold on to that idea. I'm going to clear all this, and I'm going to redraw this circuit. Okay. There's R1, there's RB. Now I'm looking at this. R1 and RB are in series with each other. If I think about what would happen if I actually looked at the current, all the current coming out of that battery is going to go through R1, it's going to go through RB. It's got no other choice. There's no junctions, there's no splits. That means that R1 and RB are in series with each other. So my total resistance now is I just need to add R1 and RB together because they're in series. This is now 30 ohms. Oops. 30 ohms and 13.3 ohms. And as a result, I will get an equivalent resistance of 43.3 ohms. And that's my answer for this problem.